So I'm just going to look at my screen. Anyways, so I'm here to talk about harnessing the awesome power of streams. Streams are, I think, the most underused part of Node, and they are what makes Node and JavaScript in general really, really amazing. So back in the 60s, sort of this recurring trope. No, I can't. Shut up. So back in the 60s, this guy Doug. Actually, I can't make it bigger. This guy Doug McIlroy was like kind of like put his foot on the ground or whatever that is and said, no, Unix is gonna have streams and I'm gonna fucking quit if it doesn't. And that's awesome. So we have streams now because of this crazy guy. But basically, streams let you treat programs as just little pieces like garden hoses that you can just plumb together. And I think plumbing metaphors are really apt for a lot of this stuff. So the first kind of stream that we have is a readable stream. And so readable streams are just event emitters that emit a data event and an end event. Maybe some other ones. Those aren't important. So we can write a readable stream here by star.js. Okay. So first thing you do, you've probably seen this before. We fs.create_readStream, and we can just like, here I've got a dictionary of like 100,000 words, and I can just pipe this, just like in Unix with the pipe character to stand it out. And if I run this, cool. So I get like all of the words printed to stand it out. What's really cool about streams is you don't, buffer the whole thing into memory first. You just can incrementally output every single piece in the stream, and that's really cool because you get the results like immediately, and lets you write a lot of really interesting abstractions. You can do some other things like end false if you don't want the stream to. If you're writing to standard out, you do that a lot. So to write a stream like without just using a stream, it's a little bit more complicated. The first thing you do for a readable stream, and this will change, so don't worry about memorizing all of this. The first thing that you do is you set readable to true, the attribute. And so here I've got just this example. It just emits the data event, and it just has a counter. So if we run that, 5.js, cool. So at the very bottom down there, you can see this infinite stream of digits that's getting faster and faster because there's more digits in every number. But if we want to say end that after 2 seconds, we can just emit an end event. So 1, 2, and it's done. Cool. So what's really cool, I mean, besides the fact that we can just pipe things around, we can actually also create writable streams from scratch. So like you might hopefully have seen this in Node if you've used Node a lot. fs.create_write_stream. It's awesome because all you have to do is just write data to it, and it ends up in a file. So you don't have to like have a big string or a big buffer and like concat all these messages one by one onto some growing thing. You can just so if I run this program and I cat output.txt, oh cool, I have the same output as in my file. So another cool thing you can do is you can take readable streams, like process.standardin is a standard readable stream, and pipe them to your writable streams. So if I run this program, which is 2, then abcdef, and we'll cat output.txt, and see that it's exactly what I typed. So that's as we might expect. But to create these writable streams from scratch is a bit more complicated. So the first thing we do is set writable to true. This is used by pipe internally to make it so that we can process.standardin.pipe to a writable stream. So we set a writable stream, and we set an end function. And of course, you have to be a little bit careful in Node because there's this convention where you can call .end with an object, and that will call .write. So that's just one thing to be a little careful of. But if you use some libraries, which I'll show you in a sec, that problem goes away. So if we run this program, we can do a similar kind of thing. And here it's just logging all of the values that I'm typing. And if I end the stream, I get a handy little end message with an exclamation point. Super cool. So we can actually do something useful here with this custom writable stream. How about let's just count all the bytes, and when the stream ends, we'll just print that out to stand it out. So here I have bytes equals 0, I plus equals the buff.length every time, and at the end, I print a byte count message. So if I run this program, ABCDEF, and I'll end it, and the byte count is 8, which makes sense because 3 in a new line is 4, and 4 is 8. Cool. So that's writable stream. The next thing that I think is super important to realize is there's this idea, this concept. I first heard about it from Dominic Tarr, who will be a recurring theme throughout this talk. It's called the through stream. So a through stream is a readable writable stream. It's not the only kind of readable writable stream, but it is a kind of readable writable stream that acts like a filter. So for instance, the grep program in Unix, it takes standard in, and it does some things, and it writes standard out. It's like from here to there. So we can make one of these if we create a new stream, and we set both readable and writable to true. Combining the previous two examples, we can have a write stream, but we can also emit data. And this is really cool. So right here, I'm just uppercasing the input that I get to make a loud stream that will be very loud for us. So I do the same kind of thing with the end, and I'll pipe standard in to my TS, which should actually be called loud stream, like LS. But so that is 3.js, ABC, hello Lisboa, and I'll end it. Oh no! All right, I forgot to pipe that. Right before I had this, so actually I have to pipe the output somewhere if I want to use it. So I'll go to 4.js and I'll say beep boop and end it, and we get uppercase messages. Hooray! Indeed. So this is a through stream. All right, and this was a writable stream. This is a through stream. This is a kind of picture I drew to illustrate what's going on. So you have a function in the middle, and you have sort of these two little conveyor belt machines that do their thing. The next kind of thing that I think is important to talk about is a pause stream. A pause stream is a sort of through stream where in Node there's this mechanism in pipe internally that helps you handle back pressure. So you call .pause and you call resume when you want it to start again, sort of like a barrel that fills up with rainwater, and then you turn on the tap to water your garden or something. Plumbing metaphors, they're quite useful. So I have an example for a pause stream. Here we can look at the first file. So this is an HTTP server that creates this output.txt file with all of the contents that we put at it. So I'll go echo beep boop, and I'll curl that after I run this program. So I'll run node0.js for this program, and I'll curl SNT magic curly package stuff. So localhost 8000. And so it tells me OK, which is right here. And now it should have written using this write stream to output.txt. So if we cat that out, oh cool, we see our message. Super great. But suppose our requirements change in this program. So maybe we have to make a directory before we can actually put the data somewhere. So we have to call fs.makedir with like a random ID. So here we'll take this code, we'll generate an ID, and we'll put an fs.makedir around that. So okay, this seems like it would work, right? We'll see. So the same thing, and instead of telling us res.end OK, we res.end on the ID. So it should tell us, whoops, and I need to run the right file, node2.js. Correct. Okay, so node2.js. Okay, cool. So now it gives us the ID, and it should be in a data directory, an output.txt file. Holy crap, though, it's empty. What's going on here? Let's just try that again. Maybe it'll work this time. Okay, so maybe if we cat out that. Okay, so that time it worked. That's a little weird. This wasn't an accident. So there's a subtle race condition in this code, right? We're calling fs.makedir, and then we're piping to our writable stream. And so you can get in the case where data events have come in before our callback fires for the fs.makedir. So how do we get around this? Pause streams, of course. So if we alter our code a little bit to do, where the heck is pause stream? All right, so we require it, of course, first. It's called pause-stream on npm. All right, and so we'll make one, and we'll pause it. And then, instead of piping our request to the WS object, we will pipe it What did I even change just there? I'm not even sure of anything anymore. Okay, ps.pub. Okay, let me just jump to the last one. Okay, so we pipe our pause stream instead of the write stream, and it's pausing, and then at the end we call resume to resume it once the callback is actually fired, not like eventually, maybe some data is passed, maybe not. No, we actually will resume it, and pause stream will buffer the data for us. So if we take our existing example and run the updated version, and we curl to it, so we'll cat out this output, make sure, okay, it worked that time. So you might notice that it prints out the ID, so we can actually cat data and do some like Unix hackery there, output.txt. Okay, so now it's catting the file that it outputs, and now, as you can see, every single time we're getting the correct output. So we just eliminated that race condition where we could get data with pause stream. Pause streams are great. So, whoops. The next thing is a duplex stream. Duplex streams are also readable, writable streams, but duplex streams are really cool because they're like a telephone. It's not just a filter like grep, like a through stream, but it's sort of like a conversation. You have side A that talks to side B, but then side B needs to like talk back to side A, and there's sort of this circular, ongoing communication. If you see a.pipe B.pipe A or something like that, you most definitely have a duplex stream. So there's a sweet module called duplexer that was actually taken out of this other module called event stream that lets you take like a readable stream and a writable stream and like smush them together into a duplex stream. Duplex streams are sort of like the Voltron of streams in that respect. Especially when you have like a request and response object, you can sort of like glom them together to make this duplex stream. And that is really cool because you can like take other duplex streams and take the request and the response and pipe that to another stream and pipe that back to the duplex because duplexes are awesome and like that. You'll see a lot of that here in a sec. I actually skipped a section, so another kind of through stream that I definitely want to talk about is called Json stream. Json stream is really awesome. So suppose I have a 125 megabyte JSON file for all of the property boundaries in San Francisco. This file exists and it's awesome. I've rendered it. It took like 3 hours. But so like if we just straight up like try to load this all into memory, you're gonna wait a long time. That takes like several minutes to actually load. But if we use the power of streams here with this module called JSON stream, we can actually make some progress. So say, going back to the streams, say the value that we want to get is the the coordinate data. So that's inside the features key, but that's inside of the geometry key, but that's inside of the coordinates key, and the coordinates key is the thing that we actually want to use. So how do we do that? We can use JSON stream, and JSON stream.parse takes an array of sort of like key values, not just key values. You can actually have like some patterny things. So features is actually an array. So if we want every element, we could specify true instead of a string name. And then we can look up the geometry key, and we can look up the coordinates key, and here we can just like console.dir the values and take a read stream and pipe that into our parser here. And so if I run that program, maybe I forgot a step here. Oh, I'm still in the pause stream example. That's why you guys should have caught me on that. Okay, if I run this example, okay, sweet. So instead of like just, fs.read file or whatever require citylots.json, we don't have to wait for that to load the whole damn thing into into memory. We can just like start processing it right away. And what's really cool too is what we get is actually a stream. So suppose we want to make like some batch transformation that's going to read in our stream and like write it back out to a file. No problem. We can use JSON stream.stringify for that. That's like the counterpart, but streaming for JSON. So we can do a stringify.pipe to a write stream, here chords.json. And so if I run this file, which is 9.js, so okay, it's just sitting there, but that's because it's actually writing to this file chords.js, or chords.json, sorry. And if we monitor that, we'll see it's actually growing continuously. That's because our stream is letting us do that. It's, we don't have to buffer the whole thing into memory, which is really, really important if you're writing scalable web services, which if you're writing Node, that's what they're really good at. So yes, use streaming JSON parsers where possible. So the next crazy thing that I want to show you is called Scuttlebutt. Scuttlebutt is, okay, oh yeah, dnode is another example of a duplex stream, which we will get to in a bit with the craziness still to come. So Scuttlebutt is, the term comes from this nautical term for a water cooler, basically. And so Scuttlebutt is a gossip protocol. That's where you have, all of these people or all of these nodes in a network that sort of talk to each other. And there's not like a canonical source of data. They sort of just have to pass messages around in order to have an entire state. And it's eventually consistent, which is awesome. It's a history-based algorithm. It's crazy awesome. So, so to use Scuttlebutt, here I'm just using the Scuttlebutt model. And for like a more practical example, you can actually check out this module called CRDT. But so Scuttlebutt models, we can just create some streams for each of them and like set a value here, set a value on node A, pipe that to node B, and if we run this, cool. So we actually got an event on node B, even though we set the value on node A, and we're just piping here, so we could actually do that over a network connection. So here I've got an HTTP server. And we'll just do a similar thing where we sort of have keys and values. And this part is really cool. So if the first argument is a port number, so we'll list on port 8000. And we can curl to this. So that's getting key A, but I can set it if I put an equals. So now if I get key A, it's a 5. That's neat, and I can do that as much as I want. But if I spin up another server on port 8001 and connect that with Scuttlebutt to port 8000, now I can curl localhost 8001 the key A, and it's the same, and I can actually set it to a new value and get it on port 8000, and that value is propagated. But it gets cooler because we can actually connect. It's not just like a client-server thing. We can actually connect. Like here, I'll spin up a new server on port 8001, but I'll only connect it to port 8002 to port 8001. And if I try to get or if I try to set a value on 8002, and then I get it on 8000, it should be the same value, and it is. This is because, so port 8000, the server on 8002 is not directly connected to 8000. It's only connected through the server 8001. And so basically, if you have connectedness in your graph of streams where everything is piped together, the whole state of the entire network will be eventually consistent. You can just set values and get them elsewhere. And you don't have to worry about like having a client or a server and having a cluster of databases that peer to each other, which, and I will totally rush through this next part, is, skipping that, this craziness. So, don't worry, I will go very fast, and it will be so awesome. So let's build a streaming web app that synchronizes data across all users, listens for server events, has an RPC control interface, runs multiple streams over mux/demux in Node in the browser, and load balanced across multiple servers that are peering with each other over Scuttlebutt, which is a gossip protocol. Okay, that sounds awesome. Let's do it. So first thing we need to do is we'll create a Scuttlebutt model, and we'll create a web server. And here the web server will just listen on the port. So, whoa, what happened? Right, yeah, I was going too fast. That's crazy. Okay, so we create our web server. We'll create a stream, right? We'll just call scuttlebutt.createStream. And then we can just add in a thing here. So if you're familiar with CouchDB, it has this sweet replicate API, but what kind of sucks about it is you can only, it's sort of only, it's for like servers connecting to clients, but with this, anybody can connect to our server and replicate, and not only replicate from us, but replicate to us, and that information will be passed around our entire network over streams. It's going to be really awesome. Okay, so some other things. We'll use this other module I wrote called emitStream to turn an event emitter into a stream and then back into an event emitter again. So we can use this other crazy awesome module called muxdmux, which was mentioned earlier today, which was awesome. And that lets us take multiple streams, pack them into a single stream, and I have a picture of this. Well, that's emitStream. Oh no, where's my picture? It was awesome. Anyways, it doesn't matter. So we have our muxdmux, and that just like is a crazy radio thing. So we'll set up our muxdmux. We will create a stream called state. That's for our state synchronization, and we can create another stream called events. That's for our event system, where it turns an event emitter into a stream and back into an event emitter on the other side, and vice versa. Okay, cool. So the other thing we can do is actually emit some events, and we can emit like a part event also when the request is done, and that's kind of cool. So this part is really freaking awesome. So we have this, that /stream thing that I showed you. So now, for every additional argument past the initial argument that I give, which is the port number, it will connect and replicate with, in a peering fashion, every other web server. So we can just have multiple web servers. They all talk to each other. They all use a gossip protocol to communicate all of the state across all of the network, and it's eventually consistent. And we can plug this directly into browsers also, which is the next part. So after some logging stuff, here's our web server. And so we can use shoe, which is a module that I wrote. All it is a really thin wrapper on top of socks.js that gives you a stream. That is all it does. That is amazing. You don't have to have like a weird Redis-y thing. You can just use modules. Let's do that. So we have our stream, right? And all we need to do to replicate is stream.pipe create stream.pipe stream, and that's a muxdmux connection. It's exactly the same as our HTTP streaming connection to replicate the state. So we wrote a function, it returns a stream. We can use that anywhere to replicate anywhere. Browsers, servers, like other servers, it doesn't matter. We just send state and the network figures it out. So there's some plumbing in here too. I snuck in dnode into this example also, just because why not? So here I have a function that I've defined, and it's dnode. So, and with muxdmux, all you have to do is create an additional stream and just like pipe it through, and that's all. So to recap a little bit, we have a dnode stream. We've got muxdmux. Here's our browser code actually to render this. So it draws a big blue box, and what's really cool is we're using actually exactly the same modules. You wouldn't actually know, except for maybe this document.body, that this is actually browser code, because we're using scuttlebutt, we're using muxdmux. It's all just browser-fied up. We're using emitStream, just the same. It's pretty much the same code, except it has DOM stuff in it. So if we go through all of this, we'll just recap here a little bit, and then I'll actually run it, and then I'll be done. So we synchronize state across all users. We listen for server events with emitStream. We run multiple streams over muxdmux. We load balance across multiple servers, or so I'm telling you. I haven't actually demonstrated this yet. In Node in the browser, and we have an RPC control interface with dnode. So that is all of the things. So let's actually run this beast. So the first thing I'll do is I'll browserify the last version that was any good. So static bundle.js, because I think I was messing with it earlier, and then I'll run browser. So I'll run the server on port 8000. Cool, and I can visit it. Hello, Lisboa. That's from dnode actually. And here I just have a box. The box, it's not very fancy. All you can do is drag it, right? But if we have another user connected, and if I make it smaller again, goodness. Okay, so if I move the box over here, Cool, it moves over there. If I move it over here, it moves over there. You might have seen something like this for Socket.io. And it's great. Like, that's super useful. But that's not interesting enough. Let's actually have a load-balanced server. So we will run another server on port 8001 connected to our other server on 8002, connected over streams and over everything. So, oh goodness, and there's totally a bug in this. Oh no, work, damn it. I'm telling you that this totally worked earlier, sort of. Oh, there it goes, yes. So it totally is working kind of a little bit. There's bugs in it, but like that's the basic idea. That is all that I have to say. Look at some pictures. Use all of these modules. They are amazing. Thanks.